Welcome to vBrownBag. I'm Alistair Cook, and this is our very first sponsored podcast. So we're doing it a little bit differently. This has been recorded with just a few of us quietly on the side, but it's a really interesting content that we've got. So we're going to be talking with our friends at Ravello and a new friend at Oracle, and we'll have a look at the things that they announced just last week around the new capabilities of the Ravello cloud. So joining us from vBrownBag, hey, Chris Williams, how are you doing today?
I am doing great. Thanks for asking.
Cool. And also, I think, Michael, Michael Wilson, have you been on the vBrownBag podcast before, or have you just been an avid listener and good friend of ours?
I don't think I've been on the podcast. I've presented a couple times, but this will be the first time as a panelist in this sort of venue.
All right, and Chris, Michael, and I will be asking questions as we go through and learning quite a lot about what's changed and what's new. And so I'd like to hand over to my friend Navin, who what was your role with Ravello before it was acquired?
Hey, Alistair. Thanks for having me and Clay on the show today. So yeah, at Ravello, I was one of the founding team members of Ravello. I'd been there since the beginning, and I ran the product group. So that was my role, and that's where we met, I think, quite a few years ago.
Yes, I saw the Ravello product way back at the Atlanta OpenStack Summit and immediately thought this is the coolest thing that I've ever seen. The ability to run those layers of hypervisor, and particularly when eventually vSphere got put in. And even at that conference, I was talking with the other vBrownBag crew who were there about getting my Autolab on top of Ravello, and then it turns out a year and a half later we did it. And that was really cool.
Yeah, we did it. We did it, and not only did we do it, it's, I think, still one of the top downloaded, or not downloaded, but copied blueprints in the Ravello repo. So yeah, congratulations.
Nice. So that's worked out nicely for us. And Navin, you're joined by Clay, who I had the pleasure of listening to at the first Ravello Blogger Day earlier in the year in Silicon Valley. And Clay, would you like to introduce yourself a little?
Yeah, so my name is Clay Magouyrk. Thanks for having us, Alistair. I'm a VP of software development at Oracle Cloud Infrastructure, and we're going to be talking to you guys today about some of the work that we're doing at Oracle, and specifically how it's relevant for a lot of what Navin and his team are doing with Ravello, but also in general how it's relevant to, I think, a lot of the users of VMware stack in general.
Excellent. So I think since you are well prepared, I'll just hand over to Navin to head straight in, and we'll interrupt and ask questions as we go.
Yeah, thanks, Alistair. So yeah, I think as a lot of your listeners probably know a little bit about Ravello, so I'll be sure to take them through some details in my section. But really from a high level, it's all about being able to take enterprise data center workloads, which run primarily on VMware, let's say, and run them in the public cloud without making any changes at all. And that's sort of always what Ravello has been focused on, and that's one of the main reasons that Oracle acquired us, because that's an inherently sort of strategic capability. But what I wanted to focus on really was the announcements that we made in the last few weeks around all the enhancements and improvements that we've done to Ravello. And you'll see that a lot of what we're talking about, especially when it comes to hardware-assisted nested virtualization and all that, and getting a lot better performance, a lot of that depends on the underlying cloud. And with Ravello now being a part of Oracle and us being able to sort of own the whole end-to-end stack, if you will, from the top to the bottom, it gives us a lot of advantages, I think, and allows us to do a lot of very interesting things. Some of what we've done with Ravello is just an example of that. And a lot of this is enabled by the core underlying cloud. So I thought it would be interesting for your listeners to be able to hear from Clay, who can give you a good foundation of the Oracle Cloud infrastructure. And then I'll talk a little bit about Ravello and talk about how we're using some of these capabilities. And it's because of that unique sort of nature of owning the whole thing that we can do a lot more with Ravello now than we could earlier. So with that, I want to turn it over to Clay. And Clay, if you can take us through Oracle Cloud Infrastructure, that'd be great.
Absolutely. I'm going to try to, so Simon, are you going to give me control of the slides, or is that something that, it looks like
This is, it's me, Navin. I've got the clicker here right now.
Okay,
So
great, cool. You can anticipate, so I'll just leave a very awkward pause in the middle between each slide, and you'll figure it out.
All right.
And thanks guys for attending, and feel free to interrupt me at any point. I can go on and be very verbose, so just stop me and interrupt. To set a little bit of background context, so I joined Oracle a little over 3 years ago. I've been a cloud infrastructure person for many years. Before I joined Oracle, I worked in Amazon. I worked on Amazon Web Services for a while. But several years ago, Oracle really took a step back and decided, hey, we think there's a big opportunity to really take a fresh look at cloud infrastructure and meet some of the needs that our customers have that aren't being met. And so we started a large amount of investment, and that's been an ongoing investment over the past several years. It's going strong. We've made a lot of progress. What I'll do is I'll go through kind of from our tenants on down how we've approached building what we view as a very important additions to cloud infrastructure in general. And then I can also talk a little bit about some of the things that we've launched and some of the things that we've done to enable specific use cases like Ravello and VMware in general. And then I'll pass it over to Navin, who'll talk to you guys about particularly relevant stuff that you guys are interested in. So as a basic premise, a large part of what we view as cloud infrastructure is very valuable to everyone. So everyone's moving to the cloud these days, and it's for the reasons that people expect and understand. You know, elastic, just-in-time provision resources, paying for what you use, everything is self-service. You don't have to wait on somebody to respond to you. You can do it over an API, et cetera, et cetera. But then the other reality is that when you look at like a lot of enterprises, whether it's an enterprise or it's just a very important, you know, enterprise-style use case, there are expectations that are often hard to meet in the cloud with respect to security and governance and control. A big part of this is about flexibility, meeting you where you're at. Typically, large companies and interesting workloads have legacy with them. That means you can't just write everything from scratch. There's an expectation around performance, reliability, SLAs and contractual terms, interesting requirements around predictability of billing and understanding of pricing, and then also the need for a complete integrated application stack. So we believe that's something that there's an opportunity. And so really what we did is we took a fresh look at cloud infrastructure, and we went out and tried to attack those problems. So being Oracle, obviously you can imagine that we make it very important to us that we support Oracle workloads very well. But we also did a bunch of work to make sure that we support all kinds of workloads. So in our perspective, if you give people the right basic building blocks, the right Lego bricks, what ends up happening is that customers can plug those together in interesting ways, sometimes even in ways that you didn't envision, and you get out of their way. A different way of thinking about this is I see the current biggest barrier to cloud adoption for most customers is that the cloud in many ways is supposed to provide a virtualized data center, but a whole lot of the virtualization has actually not been filled in. Expectations around storage, expectations around networking, expectations around control, they just aren't there. So a large part of what we've done, go ahead to the next slide, Navin. A large part of what we've done is we've actually taken a step back and plumbed things down to a more basic level. So one of the things that we did is we focused on off-box virtualization. What that means is that by doing virtualization off the box, so it doesn't actually, isn't required to be in the hypervisor, it enables us to do many things. We actually provide customers full bare metal servers, but we provide that in a fully pervasive virtualized network. We also plug in things like Oracle engineered systems into that same virtualized network. All of that is built into a very high bandwidth, low latency, highly scalable CLOS network. It's non-oversubscribed. we put that into a region of what we call availability domains, or if you're familiar with, say, Amazon or Google availability zones. And then we plug all of that together, whether you want, bare metal servers or VMs, or you want containers, all of that exists in the same cohesive ecosystem with easy access to VPN service, easy access to things like Fast Connect with MPLS peering or direct peering over in a colo hotel. You wrap that up in what we think is actually very interesting and novel ways of organizing your resources, which we call compartments, which is a way to compartmentalize many different users within a single account. And you wrap all that together, and it provides a very strong infrastructure foundation for the next generation of cloud applications.
So, Clay, there's a big piece in this where shifting the network virtualization out of the virtualization host and into the physical network opens up this functionality, isn't there? This is one of the big differentiators for this service, is that network virtualization isn't reliant on a hypervisor.
Absolutely, because it opens up many things, right? So it enables us to offer bare metal, which for certain customers, that means that they feel much more comfortable with the security controls, because we're, as a cloud provider, we're not actually running anything on your host at all. You own the entire physical host. It enables things like bringing your own hypervisor. So suddenly you can actually bring your own hypervisor over, whether that's a Ravello hypervisor or KVM or it's Zen or even VMware. You can actually run that hypervisor directly on top of our bare metal servers. It also enables us, by doing off-box virtual networking, it enables us to plug in different types of devices. So we've done that today with Oracle's premier engineered system, which is Exadata. So we can actually go in and plug in these engineered systems into the network, and we don't have to, so we can plug these things into our cloud without having to, kind of homologate them into our ecosystem. But you can imagine us doing that with more and more types of devices, whether they be, for example, networking middle boxes or firewalls or load balancers or anything, in essence, can be plugged into this cloud ecosystem that has an Ethernet port. And that's been very, very powerful for us so far, and we keep finding new ways to integrate different types of systems into our network. Does that answer your question?
Yeah, and it raises an interesting possibility of having a non-x86 CPU architecture in there, that I could have a Spark-based compute node rather than being required to run everything on x86, and that could save me from a big redevelopment effort of the software that I've had running on Solaris in the past.
Absolutely, because, and right, one of the things that slows down a lot of cloud providers is that for them to integrate these systems, they have to really match exactly all of the software they've built that kind of runs into the hypervisor itself, and that actually becomes a big barrier. And so by removing that barrier, you can plug in a variety of different things. So this is kind of just going over to make sure that we don't come across as the cloud for So sometimes when I talk about the ways in which we are differentiating, people walk away with saying, hey, that sounds cool, but does that really cloud? Are you actually just a hosting provider? And so I wanted to make sure that it's very clear and understood that no, actually this is very much cloud. What that means is that you can sign up with a credit card, you pay only for what you use, you get a global account, money can be used anywhere. You have the same availability primitives that you expect out of the most highly available cloud infrastructure providers anywhere in the world. You can launch resources. So bare metal servers take on the order of 4 minutes. VMs are about a minute. You get an amazing set of storage primitives, whether it's object storage or block storage primitives. Very elastic, pay for what you use. Everything is available over standard APIs. You get an SDK, CLI. You get a very interesting web UI. So those in many ways are not ways in which I'm saying we're differentiating. Those are required table stakes to kind of be talking about being a cloud infrastructure provider. And so what's interesting is, where do you go from there after that? So go ahead, Navin. There you go. So some of this stuff, we've focused a lot on security. By doing bare metal, it also requires us to do a whole lot of isolation down into our network. We have very segmented internal network isolation zones, and we do things like reverse path checks and anti-spoofing detection between our computers. We also support defense in depth. So the way in which we actually architect our systems, when we build bare metal, and then we ourselves, for example, eat our own dog food. So our virtual machine offering runs on top of the same bare metal that we offer to customers. What that means is that you end up with a double layer of protection, because even if for some reason a hypervisor is compromised, you still don't have any more access than a bare metal host would anyway. And it also means that we're not providing anything special to ourselves. We're using the same primitives that we give customers. Everything is also pervasively audited and automatically stored in our audit service. I wish that I was better at explaining compartments. I find it's one of those topics that typically starts off as a 1 minute and then ends up being an hour-long conversation. So I'll try to do it briefly. In essence, the real problem we're trying to solve with compartments is large organizations want to buy a single account. They want to be able to manage, for example, resources and budgetary. They want to have one contract, with a single account, but at the same time, they want to be able to have lots of different departments or lots of different people within the department share that account. And so what we've done is we've created the concept we call a compartment. And you can think of it as kind of like a virtual space that controls access to all of your resources. And then we have pretty much all of our access control happens at the compartment level. The easiest way to imagine this is you could have, say, a development compartment and a production compartment, and you actually can place your production network and your production computers in the production compartment, and you can have the development computers and development network in a development compartment. And then what you do is you grant access to the, say, development group only to development, and you can say grant access to the production group only to production. That's a very basic use case, and it looks kind of like you can think of it in the sub-account kind of manner. But where the real power of compartments happen is that you can actually, for example, put all of your production network into a networking compartment that, for example, you only let your networking admins have access to. But then you can have a line of business. They can have their own back office compartment, and they can launch computers that attach to that same production network in the production compartment that the network administrators control. And so what you get is you get the ease of use. If a customer just wants to show up and create a simple, single compartment, and they just want to create resources and not worry about it, you can do that. But if you actually want to have a high level of control and visibility into your resources for a large organization, compartments provide that. And we've coupled that with what we think is a very interesting way to approach policy. So we have a very simple natural language policy language, which allows people to write policies that control access while still being understood. Because what we found from our cloud experience is that it's not so much about being able to write the policies. It's about being able to audit and understand those policies and verify that the policies that you expect to be there are there and working. And compartments are also where we do things like hang quotas and cost controls off of within an account.
So trying to understand the compartment a little bit more, is this like a nested and tree structured, or is this that an object, and it might be a network would be an object, a physical host would be an object, a VM would be an object, that each object lives inside a single compartment, or can an object live in multiple compartments?
Sure. So that's a great question. As of right now, like literally today, we support compartments that are one level deep. But what we actually do is we're going to be launching in the next couple of months the ability for nested compartments. And so you can imagine how powerfully that works, where you can actually have multiple layers of hierarchy. The other thing that we're adding is it's actually possible to move resources between compartments. And that actually enables interesting use cases as you have things like mergers and acquisitions and groups being moved around. You shouldn't have to kind of, we're in the cloud. You should be able to move resources where they are logically controlled, separate from where they were originally created.
So it kind of sounds like compartments are close to tenants almost under the VMware world.
Possibly. I have to admit up front, I probably should have had this disclaimer. Navin has so kindly invited me, but I am not nearly as well versed in VMware as many of you are. I pretend to talk about VMware only on stage and on calls like this. But from my basic understanding, I think they are to some extent, but I'm not entirely sure. Next slide, Navin. Thanks. So one of the other big areas we focused on is meeting enterprise customers where they are. For us, that means, for example, not, I think one of the interesting quotes, ways of putting it is that you should be able to, bring your present and build your future. So what that means is that if you want to be able to treat our cloud like it's just an extension of your on-premise data center, you can do that. You can create a virtual network extension. You can actually pixie boot these bare metal servers off of an on-premise pixie server and treat them just like they're an elastic extension of your data center. So you can bring, the OS that you want. You can bring a hypervisor that you want. But you don't have to do that. You can also, we can manage your VMs for you. We can manage containers for you. There's a whole bunch of options that we can manage for you. And then, of course, being Oracle, we have a large investment in a customer base that cares a lot about engineered systems, and we offer engineered systems like Exadata in that same ecosystem. Next slide, Navin. One of the things that we've really focused on is high predictable performance. Open World is a big conference that Oracle has. It's happening next week, and we have a bunch of announcements that I can't share just yet that are coming out next week that have significant improvements to some of the stuff I'm going to talk about here with respect to performance. But at a high level, what we really focus on is predictability, meaning that protecting you from noisy neighbors, not giving you a lot of oversubscribed resources and then telling you they're not oversubscribed. We offer the full gambit of scale down options, small VMs, medium-sized VMs, et cetera. But we also offer very large shapes, 36 cores, over 28 terabytes of SSD. You can get millions of read and write IOPS, full bandwidth to the host, 10 gigabit network. And then you kind of get the control and flexibility for all of your most important workloads. Next slide, Levine. We also have something that we're very proud of. We put a lot of energy into our remote block storage, where we offer based on our testing and our extensive usage, what we consider to be the best in class remote block storage. It's interesting in many ways. So we offer it at a single low price. It's 5 cents per gigabyte. We don't offer 4 or 5 different tiers of storage. What we also do is we basically take away any need for you to worry about IOPS. So we offer 60 IOPS per gigabyte, up to 25,000 IOPS per volume at a very low latency. And we allow you to attach those to your compute volumes, your computers, compute instances. And then of course you can do whatever you want to with those block storage volumes. Next slide. We've made a significant effort into making sure that our pricing is transparent and simple. So we have a relatively simple price sheet. We don't gouge on pricing. So for example, we have one metric for internet egress. And it's 1 penny per gigabyte compared to typically 9 to 10 cents for most of our competitors. We don't have a bunch of different shapes and then cause you to understand, what is the pricing. We charge you for cores in a certain family, and then if you have 4 cores or 8 cores, it's very simple pricing. You just multiply those numbers by 4 or 8. Something else that Oracle has that is very interesting. Some customers like it, some customers don't. And I'll preface this by saying we do offer full pay-as-you-go as any other cloud provider does. But instead of requiring customers to do things like reserved instances, what we offer is what's called monthly commit. So if you sign up for a commitment of a certain dollar amount, whatever that dollar amount is, for, let's say it's $1,000 a month that you commit to using. Then what happens is you get an automatic discount of 15% across the board on anything that you spend that $1,000 a month on. And there's no commitment to any specific instance type. It applies to whether it's network pricing or storage, et cetera. So you don't have to have this kind of complicated game of predicting your exact usage and then reserving instances ahead of time. Next slide, Navin.
That simplicity in pricing is kind of a surprise from Oracle or from any of the big vendors. Is you usually expect extensive lists. That's really nice and rather surprising.
Yeah, well, what we found we aim to please. What we found is that it's one thing to have complicated pricing on something that's kind of negotiated as a deal up front. What makes cloud complicated pricing so difficult is that it makes it very hard to predict the bill. And so, if you're a startup paying with a credit card, that's less of an issue. But when you're a large company and you have very strict cost controls, let's imagine that you're managing to an EPS target, or you have a bunch of internal accounting that needs to happen. Being able to understand what are the few prime movers and how much you're actually paying and how much the bill's going to be is very, very important for customers, we found. And so if you don't do that, it actually makes it difficult for certain workloads to move to the cloud, because it just becomes impossible to actually predict how much things will cost. And sometimes even people are willing to pay more for that predictability. We don't actually require that. We actually are happy to people to pay less for the predictability. But the reality is that it's very important for a certain type of customers.
How detailed is the chargeback for it? Does it go ahead and the bill comes back and you can actually charge it back to different compartments, or?
Yeah, so there's metadata that gets sent back so where you can do proper cost accounting. Now, something that is not launched just yet is we're launching pervasive tagging throughout the platform, and that'll happen in I think in November. And once we have that tagging released, then you can imagine that those tags will also flow through the billing system as they would with other cloud providers. And that becomes very useful for very detailed billing. But yes, the most coarse-grained allocation is there today.
For the customer, so what is the in terms of going with the billing stuff? Do you have customers that have multiple accounts and then you have like a master payer account on top of that, or do you use the compartments as your compartments and tagging as your billing hierarchy for the individual groups?
Sure. Well, what we've found is that it very much depends. So it totally depends on what the customer wants. So for example, sometimes customers want completely separate accounts. You could imagine that there's a company that's a global company, and they do business such that the European arm is completely separate than, say, the North American arm. In that case, typically they want separate accounts, and then they still want, but typically they'll want to have like some kind of master payment agreement, which can be kind of separated out, where you have a single payment instrument that gets attached to those two tenancies. And then you can also imagine that there's certain companies that want a single account, and then they end up doing, billing and cost control deeper within that same account via compartments.
Okay, so both. Awesome.
Yeah, and really there it's, and I hate giving customers choice where it's not necessary, but it really comes down to how the customers want to transact business, and you have to kind of give that flexibility where it's needed. Something else Dyn is a DNS company. We, Oracle, acquired them starting late last year, and we actually kind of closed the acquisition in April of this year. And we're going to be announcing some stuff at Open World. I won't go into the exact details, but some very interesting stuff where we've done a lot of integration work with DynDNS and some other services that Dyn have. Really, this is about our overall strategy is that in some cases where we go off and we do things our own way, but in cases where we think we can actually, integrate best of breed offerings, we're here talking about Ravello, for example, and also DynDNS. We go out and we acquire, but really I think of it as more as a partnership with the engineering teams, and we work together to build what we feel like is the right cloud platform for our customers. And so that's one of the things that we've been working with Dyn on, is really a few things that we're focused on is how do we bring the power of public DNS into the private VCN? So you have a virtual network. How do you actually get those same kind of best-in-class DNS features within your virtual network at no cost? We're not quite there yet, so that work is not done. But that's absolutely where we're going, and you'll see that over the next few months. So you can imagine that, even within your virtual network, you should be able to set up, automatic failover and load balancing and health checks and traffic steering within your virtual network. And then as you take your service to production, you get that same set of features out on the internet. Next slide, Navin. And we're doing more than just DNS, so you can imagine the obvious things that we're doing that kind of as we work out towards the edge with respect to different types of edge services. I won't go into the exact details, but you'll see us announcing more of those as we go forward. We're doing close partnerships with Dyn and adding a whole host of new services to kind of fill out the complement of things that you'd expect from any large cloud infrastructure provider. Next slide, Navin. Perfect. And so I think that at a high level, that's kind of what we've been doing from a cloud infrastructure perspective. To kind of recap, as of the Friday, we will actually have 3 regions available. We have one in Phoenix today and one in Virginia, and we're launching Frankfurt on Friday of this week. We're building more regions around the world. We're rapidly expanding both our engineering effort and our overall global footprint. We are focused on building the right cloud infrastructure for enterprises across the board, being the best place to run Oracle. And part of the reason why we're here today is that we think we're also very compelling for a lot of VMware workloads.
Does any of your regions have specific capabilities that other regions don't, or are they all based off of the same capabilities?
No, those 3 regions all have the same fundamental architecture and feature launches. In general, right, like typically service rollout will have some delay, but for example, at launch, everything is available everywhere. And then anytime there's caveats, we kind of highlight that. But as of right now, there are no caveats. And so Navin, now you're up.
Thanks, Clay. So let me turn it over to Alistair. Alistair, do you have any additional questions for Clay before we dive into the Ravello piece of it?
The only other thing I thought about is whether Clay can share any plans for further regions. That the 3rd region in Frankfurt, down my way in Southeast Asia, is somewhere like Singapore or Hong Kong on the plans that he can talk about.
Yeah, so we do have plans. I am not supposed to talk about those plans probably on this call, but you should expect some things coming your way very soon.
All right. Okay. Thanks, Clay. So, Alistair and team, let's talk a little bit about the Ravello service as well now. And what I'll do is take you through. I don't like to presume that everybody out there knows exactly what Ravello is and all that. So if you don't mind, I'll give you a quick, maybe a 5-minute overview of Ravello just to calibrate all your listeners. And then after that, I'll dive into sort of what's new and touch upon how that relates to what Clay has spoken about, how we're leveraging the underlying OCI infrastructure and the kind of things that we're getting from there, which is very unique. Obviously, we can't do that with any other cloud provider. We can do that with OCI because it's ours, right? So Clay's team delivers the features that we need in order to be able to use it. And that's what I'll spend a lot of time talking about. But let's start with, from a high level, what Ravello is all about. And everybody these days is trying to move to the cloud, right? We know that for all the obvious reasons that make a lot of sense. But oftentimes, enterprises have a lot of challenges and they face a lot of difficulty in moving their applications over. And the primary reason for that is because the public cloud is very different from the enterprise data center. For example, give you tons of examples, but from a very high level, If you've got a VMware-oriented environment in your data center, you cannot use your VMware VMs in the public cloud, other than some of the new services that are coming about. For a long time, that wasn't possible. You'd have to essentially re-platform your VMs and your infrastructure in order to be able to use the cloud. Sometimes, if your applications needed, let's say, bare metal servers in the data center to run a heavy database or some other sorts of larger application components, you would have to often do P2V conversions and then move them over. And obviously, you run into all kinds of driver issues and this and that compatibility when it comes to those kinds of challenges. Another very big one is layer 2 networking, which is not supported in the public cloud natively in most cases. So this makes you have to sort of often redo your application. If, for example, you're relying on multicast or broadcast in your application, and if that doesn't work, then you've got to redo it in a lot of cases. You have to move some of that logic up into the application layer, and that can take a really long time. If your application relied on certain network appliances, like you had certain load balancers that you assumed were part of the infrastructure, or firewalls, or things like that, and that wasn't there, that's not there in the public cloud, then you've got to essentially bake that in again into the application. So a lot of times, these migration efforts are a lot more challenging and a lot more complicated than what most enterprises might think in the beginning of the journey. And I can give you an example. One of our customers is a large sort of online gaming company, and they had an application that consisted of about 250 virtual machines, mostly Windows, multiple domain controllers, load balancers, firewalls. They had 50 different subnets and VLANs literally in this application. It was really complicated to set up, even in their own data center. And they wanted to move it to the public cloud. They tried, I think, over the course of 6 months, they tried 2 or 3 different approaches, and they couldn't do it. And in their case, the biggest problem they had was primarily around networking. Just to give you an example, this takes a lot of time and effort. So what we wanted to do was, in Ravello, when we started the company back in 2011, we wanted to create a solution, an infrastructure solution, basically, to this problem, where an enterprise could now take any application, any VMware-based application environment, and simply run that in the cloud without making any changes at all. Right? So we wanted to make sure you didn't have to change your virtual machines, your networking, or anything in the application. Just take it exactly as it is, and you can now run it in the cloud, as I said, without making any changes. So at this point, I want to specify what we mean by an application. All right? In our case, an application typically looks something like this. You've got, obviously, your web servers, your app servers, your database servers, potentially some caches, and other components, but it also has networking components, including firewalls and load balancers and routers. And to us, this whole thing is your application environment. It's set up in a certain way in your data center. It's got certain IP addresses. It's using certain networking features, and it operates and runs in a certain way in your data center. And what we do is we essentially encapsulate that application environment and run it in the public cloud in our capsule without making any changes to the application at all. So it all functions exactly the same way. One very high-level way to look at it is that Ravello actually abstracts the underlying cloud to make it look and feel like an enterprise data center environment. And that way you can take an application and run it there without making any changes, because from the application standpoint, when it looks down, it sees exactly the same thing. So it doesn't really care now that it's not running in the data center, it's running in the public cloud, okay? So let me, in order to crystallize the concepts here, let me just give you a very quick whirlwind sort of demo of Ravello, so you can get an idea of what it looks like, and it might help clarify the concepts a little bit. All right, so let me go to Ravello. Alistair, do you see my screen?
We're just still seeing the demonstration slide on screen.
Okay. And now?
Now we've got a web browser up.
Okay, great. So I'm going to the Ravello website and I'm going to log in. and sign into my Ravello demo account. Okay. And the first thing you're going to see here is a list of rows, and one important distinction between this and some other traditional virtualization products is that each one of these rows is not a virtual machine. It's a full application environment. Okay, so this consists of all of your VMs and networking and the entire application, if you will. Now, let's assume for a second, before I jump into the demo, that our scenario is you've got a 4 VM application running in your data center. It consists of a web server, a couple of app servers, and a database server. And, you know, fairly standard configuration. And it's running on a VMware infrastructure in your data center. And you want to now take that application and run it in the public cloud without making any changes at all. So you go in and say, you know, create an application. I'm going to give it a name, vBrownBag demo, and I'm going to hit create. And that opens up an application canvas for me. Okay, think of this as a workspace. Anything that you do on this workspace will be a part of that encapsulated entity that's going to run in the cloud. And now I'm going to just import my virtual machines from my data center. Obviously, I'm not going to upload them right now because it really depends on the size of the VMs, the bandwidth, and all of that. And you guys are experts at this. So yeah, I'm not going to show you how to upload a VM, but I've already uploaded a few VMs here. And all I need to do at this point is drag and drop them onto the canvas. So that's my web server. This is my first app server. This is my second app server. And finally, this is my database. Okay. So if you note, I've done nothing so far other than upload my VMware virtual machines. I've not made any changes to them at all. These have not been converted in any way or anything like that. These are bit for bit identical to the VMware VMs that I have running in my data center. Okay. Now at this point, I'm ready to publish it. But before I do that, I'll click on the network tab and show you that we've automatically compiled a private encapsulated network for this application. So we went in there, and in this particular case, it's a really simple example. So it's a flat network. So we've stuck everything on the in the one subnet here, as you see, and the web server, app servers, and the database servers are all there. But I can always go in and click on any one of them and edit the network properties and change the design if I want to. But let's assume I'm fine with it for right now. At this point, in order to deploy this application to the cloud, all I need to do is hit publish and select whether I want to cost or performance optimize it. Let's say performance optimized. I select whichever region I want. Let's say US East 1. We support already today, I think 15 or 16 different regions around the world, and we keep adding more as we go along. And at this point, that's it. I'm going to select US East 1. I'm going to hit publish. And as you can see, you see some blue icons appear here on the VMs. In about 5 minutes from now, the application that was running in my VMware environment is now going to be running in the public cloud, and I wouldn't have made any changes to them. That's it. It's really that straightforward and that simple, and that's what Ravello is all about from a really high level. One other really interesting thing that I'll always like to talk about is this blueprint, where you can save this entire application as what we call a blueprint. Think of this as a multi-VM snapshot where we save the state of the disks and the network and definition and all of that as a blueprint file. So the next time you want to spin up a new version of this environment, all you got to do is go to that blueprint and create and hit publish, and that's it. You have a fully isolated environment running in the cloud. You can use it for as long as you want, and then just shut it down when you're done. It's really that simple. Okay.
So I have several thousand questions, but I'll limit it to just one right now. That's right. Fascinating. Can you modify within the encapsulation wrapper? Can you modify the MTU size of your switch? Yeah,
absolutely you can. It's a good question and a good point, because
yeah, you know where I'm going with that.
Yeah, I know where you're going with it, and also it gives me an opportunity to talk about our very newly released network editing. You see, the first incarnation of Ravello, we had a relatively simplified software-defined networking model built into our hypervisor. I'll take you through the slides, and you'll see exactly what I'm talking about. But because a lot of our customers have been asking us for certain features, we've changed the network model. So if I don't remember exactly, because this is like a really new UI, I don't remember exactly where it is, but I believe it's here somewhere. So let me double check on that and get back to you. But this is an entirely new UI, so I'll have to double check. Get back
I guess that would be at the switch level rather than on a single port.
Yeah,
It's,
so
driven
this
there.
one should be here. I don't know. Anyway, I'll double check on that and get back to you, Alistair.
No problem.
All right. So that's the Ravello demo from a really high level. And now let's talk about the bare metal cloud and Ravello more specifically. I'll actually come back to this one in a minute. So as far as the technology is concerned, I know Alistair is really familiar with this, but for some of the other listeners out here, the way we do this is we run our own technology layer on top of the public cloud. And our infrastructure layer really consists of three components. The first one is what we call a nested virtualization engine. Think of this as a hypervisor. The second one is a software-defined networking layer, where because we have the hypervisor right now and we can see all the packets coming in and out, we can implement relatively easily a software-defined networking layer inside our hypervisor. And the third one is some sort of abstractions that we've had to do to normalize all of the cloud storage. Amazon has EBS, Google has persistent disks, and we've got now, of course, all the OCI stuff as well. So to abstract some of that, we needed to implement some storage functionality in a file system, essentially. But the interesting ones are really around the nested virtualization piece and the networking piece. And our first generation of the virtualization technology was very much how VMware started, where we used binary translation. And of course, we did a lot of optimizations to that, and we used direct execution, which is a very well-known technique. We did a lot of caching, a lot of really interesting things at the binary translation level in order to provide good performance. One of the other interesting things we did was we implemented all of the VMware devices specifically. So we have a VMX.NET device, a PV SCSI device, and all of that. So when you run your VMware VM on top of our hypervisor, it sees exactly the same devices. It sees essentially the same hypervisor pretty much. And that's why it goes ahead and runs without any problem at all. So this is the core piece of the technology inside Ravello, which is this nested virtualization engine. But what we announced recently are some enhancements to that. Very much like VMware went from binary translation into using a hardware assist mode when Intel came out with VT technology a long time ago. Very much like that, Intel now has support for nested virtualization built into hardware. I think this started about a year and a half, 2 years ago. And cloud providers started rolling out hardware that had these capabilities in it. But unfortunately, the software that they used, their virtualization layer or their hypervisor, was not exposing that to guest virtual machines running on top. So while the capabilities existed in silicon, we, Ravello, couldn't really use it. But that's on the left, as you can see. So we were using our binary translation methods in general and running on top of all the other clouds. But now when it comes to our own OCI, Oracle Cloud Infrastructure, Clay and his team have been able to expose those extensions to us, which is really great, because now we can use HVX in a hardware-assisted mode, which, as you know, leads to significant boosts in performance. So very much like VMware saw a tremendous boost in performance when they went from their first generation binary translation into using VT, we see a very similar sort of a scale of increase when we move from our binary translation to being able to use hardware-assisted virtualization with BMC, okay, or with the OCI cloud in general. So that's the first point I wanted to make, and that's really huge for us. The second point is around taking this another step further, where we can now run HVX on bare metal. So as Clay talked about earlier, because of all the work that he and his team have been doing, we have the ability now to use an API and provision a bare metal instance in the cloud, which is really great, because now once we have our bare metal instance, we can run HVX natively on that bare metal instance and give you even better performance. As you know, the row in the column in the middle is still nested virtualization. It is with hardware assist though, so the performance is very good. But the column on the right is what you would look at as a traditional virtualization stack. It is just the HVX hypervisor running on bare metal. So it gives you even better performance. And it has all of the advantages of the overlay network of Ravello and being able to run all your VMware VMs unmodified and things like that, right? So it's a really interesting option as well for customers that care a lot about their performance and they want to run very performance sensitive workloads. That's something that's really interesting. Now, we've done some testing on our side, and obviously we've tested a whole bunch of different applications, everything from Oracle databases and rack configurations to e-business suite. I think what VMware uses as a multi-VM benchmark called Weathervane. We've run some spec benchmarks, and we've seen a tremendous boost. It, of course, really depends on the kind of workload that you're using and whether it was I/O bound earlier or not, and whether it was network I/O or disk I/O, and you see different levels of improvement. But we're really excited because in some cases, especially the ones that were pretty much bottlenecked around I/O, we see a huge performance improvement and up to 10, 14x kind of range. So really interesting for us from that standpoint, and that's why we're really keen to talk to you about this today, Alistair. Let me pause here to see if you have any questions on any of that before I move to some other advantages of being able to run Ravello on the OCI infrastructure that Clay talked about earlier.
I'm interested in the decision point around, for a customer who's going to run Ravello on the Oracle Cloud, between running inside VMs on Oracle Cloud or bare metal. Where do you see that decision being made?
It's a good question. I think a lot of it is going to come down to performance and I would say also predictability of performance. Like, for example, if you've got an application that's fairly large, let's say it's got about 10 virtual machines and each VM has about 2 to 4 vCPUs, and they've got decent amount of memory usage, you would be able to do good justice in a way to a full bare metal box. Okay, a full bare metal box has 36 vCPUs with I think about 500 odd gigs of memory. So maybe a little bit less, but in that range. And if you've got a huge application and you can take advantage of that, you can very easily just run it on we call a bare metal machine in this case, and get a pretty good improvement in performance. The pricing and all that, we're going to be announcing that in a little bit going forward, so I can't talk about that too much at the moment. But it'll be economical for you to do that. It would make sense from a performance perspective, and that's really, I think, the way enterprises would look at this thing. Okay. All right. So in addition to getting better performance, as you know, one of our in the previous incarnation of our hypervisor, or basically when it's running in binary translation mode, you could go up to a maximum of 8 vCPUs with a total of, I think it was 64 gigabytes of memory. That was the maximum that you could do as far as a single VM was concerned. You could, of course, run thousands of virtual machines inside of what we call an application environment, as some of our customers do. In fact, there's an example of a customer called SimSpace that does entire cyber ranges on top of Ravello for cybersecurity training for some of the largest banks and defense organizations and all around the world. They literally deploy thousands of virtual machines inside one application environment. So that element of scalability has always been there. But as far as the individual VM was concerned, you could only go up to a maximum of 4 vCPUs and 64 gigs of memory. Now you can go to literally 32 vCPUs and 200 gigabytes of memory per virtual machine inside that application. So much better performance, much bigger virtual machines. We've also got a high availability feature that we've introduced in the product right now. A lot of enterprises that deploy production workloads on Ravello have been asking for this for a while. And essentially the way we've implemented it is that you can specify that a particular group of virtual machines or a pair of virtual machines as a failover pair. And we will make sure when we do our cloud fitting algorithm on the back end that we're scheduling these VMs on host VMs or host physical servers, that we will always place them in different availability domains by definition. So now you've got, you know, a redundancy built in there, which would significantly help you in case there was downtime in one of the data centers. You still had a good portion of your application running in the other data center, right? So this is a very important feature that we've also just introduced recently.
It's a really cool level of availability that you seldom see in enterprise data centers, because that's essentially splitting your application across two data centers, but still with that same software-defined networking that spans those two data centers, which is a really nice piece of availability.
Yeah, it's really interesting, and you know, you can click on any two VMs, select them to be a failover pair, and we'll take care of it for you. Our networking will make sure that their IPs are exactly the same and that they're reachable in exactly the same way. DNS, DHCP, all of it will work, and we take care of all of that in the underlying infrastructure in Ravello.
Does there have to be? I'm sorry, Matt. Does there have to be any sort of special flag that needs to be set, or does it automatically work if I have, for instance, a VMware HA group or HA set that I go ahead and move over to it?
You would have to tell. No, you would have to. Yeah, it's a good question. You would have to tell us that these two VMs or this group of VMs is in an anti-affinity pair, and we would take care of it then. We won't be able to inherit the VMware property if it was set in vCenter. I don't believe that's supported today. Okay, so where are we going with all of this, right? And this is what I wanted to spend just a couple of minutes to wrap up with you guys. So you've seen that Ravello can move your VMware workloads to the public cloud. We've done a lot of work with our friends and colleagues in OCI, Clay's team, to make Ravello perform really well on OCI compared to other clouds, because we now have a fully integrated stack. We can go all the way down. So we've done the performance work, we've done some work on availability and all of that. And really what we're seeing from most of our enterprises is that it's the data center is a complicated environment, right? It's got many different kinds of applications. A lot of them have legacy components and things like that. So where we see ourselves adding a lot of value to our enterprise customers is the ability to now take your VMware workloads. So most of the times they're web servers, app servers, and other front-end and middle-tier components, and simply move them over using Ravello on top of OCI, the way I just showed you right now. You'll get great performance. You can run big VMs and all of that. So we feel, you know, good about that. That's the top, you know, circle out here, right? So you move those components over using Ravello pretty easily. And as Clay showed you earlier, you can use the bare metal cloud to provision, you know, which is a brand new infrastructure we've built. You can use that to provision bare metal servers. You can run your Oracle databases there. You can run other very performance sensitive workloads where you just need to run on the metal. You can do that in the bare metal server piece of it. And because we've spent time integrating these components, essentially the VCN that Clay talked about earlier, the virtual network, the construct that's part of OCI, you know, those two can be peered, and essentially you're going to have private connectivity from your Ravello environment all the way to your bare metal VCN as well, which is really great because you can have your database there, you can have your high performance, highly sensitive, performance sensitive workloads running in your bare metal cloud or OCI VCN environment, and just simply peer that. And you've got a cloud that can accommodate everything from your VMware workloads to your bare metal workloads, and you can fast connect and VPN that back into your enterprise, and you've got you know, really a good stepping stone to start moving some of your significant portion of your data center workloads into the Oracle Cloud.
So I had another question, if you have time. I was kind of curious as to how how Ravello plays with NSX. Specifically, like for instance, the microsegmentation, all that sort of thing that goes on now. What happens when it goes ahead and gets ported over to Ravello at that point? Do the firewall rules and everything go with it, or?
No, unfortunately it works a little bit differently. NSX is an ESXi construct as a part of the ESXi environment, right? And from a high level, it would give a particular IP, whatever, to a virtual machine. It's the underlying networking infrastructure that allows the virtual machine to communicate with others. So what we do is we take just that virtual machine and we move it over. We're not moving over any of the NSX components or anything like that. So we take the virtual machine component, we move that over to Ravello, and we have our own NSX equivalent, if you will, our own software-defined network that has a virtual switch, a distributed virtual switch, a virtual router, distributed DHCP services, distributed DNS services. All of that is baked in as a part of Ravello's overlay software-defined network layer. So it's different from that standpoint. We configure that network to mimic the settings of what the network was in the enterprise. So from that standpoint, we try to get the basic networking capability over automatically. But if there's any advanced firewall rules that were set up using NSX, that will not translate over directly. You can program Ravello's distributed firewall to give you similar functionality, but it's not going to automatically take those rules and move them over.
Okay, so you mentioned before that, I think on one of the earlier slides, that it did have a zero trust model on that, so you could still do things like microsegmentation, app isolation, and that inside of there.
Yeah, you can set up different subnets, you can set up different VLANs, you can do your segmentation there, you've got firewall rules that you can set up. So a lot of the capabilities that you're looking for should be there. With regards to any specific features and stuff, if you can just shoot me an email, I'll double check to make sure that they're supported and I'll send them back to you, okay?
And the zero trust was specifically on the Oracle Cloud infrastructure that Clay was talking about rather than inside the Ravello layer.
Right.
Yeah. Okay.
All right, Navin, that was what you wanted to cover? It seems like we've come to the end of your presentation.
Yeah, that's pretty much it. So if you guys have any questions, we're happy to go through that. Otherwise,
Michael and Chris, any more questions?
No, that was fantastic. I've been a longtime user of Ravello, and in fact, you guys helped me with passing both my VCAPs 5 and 6. So I'm excited to sink my teeth into the new features and play with some NSX in there, which was why I was asking about the MTU settings.
Okay, very interesting. Yes, no, it should work, and we'll definitely be able to get you the help to set it up in case you run into any issues. But people have run NSX and they've stretched different configurations from. I know that somebody set up 2 different application environments in Ravello and stretched NSX across both of them, so it should be feasible.
And the fault domain settings that you were speaking to previously, that's set up in the blueprint ahead of time, or can you wrap that in your blueprint package, or do you specify that after everything is stood up?
If it needs to, like for example, if let's say there's a VPN device that's in your blueprint, and you spin up a new copy of it, then you need to go in and change your VPN certificate and all of that in order to connect to a different environment, right? But other than that, everything else should work.
Right, but the fault domains that you were talking about, the splitting out of VMs.
That's part of that's part of the blueprint. Sorry.
Okay, cool, awesome.
All right. Well, thank you very much.
Thank you very much.
We're doing the mutual thank you and conclusion because, of course, Navin is a pretty practiced presenter as well. So thank you very much for coming and sharing this with us. I think it's been really useful, and that I know a large number of our audience are users of Ravello, particularly through the program for vExperts. we can find more out at ravellosystems.com still, or is there an Oracle URL that goes to Ravello as well?
Yeah, just as of yesterday, you're going to be redirected to Oracle, but you can still go to ravellosystems.com and it's going to take you there.
And that's probably the easiest URL for us to find until it eventually expires. We also are planning some more vBrownBag activities with Ravello to bring you some more in-depth and hands-on experience. So watch out for some announcements on that in the coming months. So thank you, Navin and Clay, as well as Chris and Mike. This has been the vBrownBag podcast on the Oracle Ravello platform.